In lesson 5.4, we're going to be talking about the triangle midsegment theorem. Now, if you look at my triangle ABC at the top of my note page, here my point X is a midpoint. Also, point Y is a midpoint, and I know that based on the tick marks. If I went ahead and joined them together, that line right there is a midsegment. So the midsegment of a triangle is a segment that joins the midpoints of two sides of your triangle. The question is, how many midsegments does a triangle have? Well, would you agree that segment AB also has a midpoint, roughly sketched in here? Now, I could join these two midpoints to form a midsegment. I could also join these 2 points to form a midsegment. So, how many midsegments does a triangle have? Well, it actually has 3 total. If we take a look down below, the triangle midsegment theorem, again, I know they're showing me a midsegment by the tick markings. And the midsegment of a triangle happens to be parallel to the side of a triangle. So here my segment DE and my segment AC are parallel. And the midsegment is half the length of that parallel side. So if this were to have a length of 20 units, this were to have a length of 10. Or we can say that if I have my length of AC, half of AC equals DE. Down below, the diagram in the middle, I'm simply showing that you can have a triangle with its 3 midsegments. And in the questions for 5.4, they're going to ask us to do a little bit of solving, either for some side lengths or for some angle measures. And taking a look here, I can see with the tick marks, which I'll make a little darker, that I have some midsegments or midpoints. The first they're asking me to find is my length of UW. UW, this segment right here. Well, I can see it is a midsegment. It would kind of relate to this side here of ST. ST is 7.4. UV must be half of that. 7.4 divided by 2, and we would find out it has a length of 3.7. They're also asking me about finding the length of RT. RT is this bottom segment down here. Well, I can see that this segment UV is a midsegment, and so in order to find RT, my midsegment is 5.2, then we would just have to double it, and we would find out that RT is 10.4. Finding my angle measures, number 3 is wanting the measure of angle UWR. UWR is this angle right in here, actually, UWR. Well, you remember that my midsegment is parallel to a side of my triangle. So we're actually going to have some angle pairs here. UWR is actually going to be alternate interior with this angle here, which they have marked as 41 degrees. Which would mean that if we have parallel lines, angle UWR would also be 41 degrees. Number 4, they're asking me for the measure of angle SVU. Angle SVU is right in here. Well, again, my parallel lines, I do have some angle pairs. My pink line here, parallel here. This is going to be alternate interior still with 41 degrees. Taking a look at example B, They want us to find the value for x. Well, is x plus 10 going to equal x plus 2? No. In fact, we said that the midsegment is half of the base, or the side it's parallel to. You could solve this a couple different ways. I could take half of x plus 10, or I could think about doubling my midsegment, which is the way that I had set it up initially. I took my x plus 10 and knew that I would need to double the x plus 2. And then I solved for x. I found out that x is 6. So in question 2, when they want to know the value for ln, we can simply take that and plug it in. ln must be 16. Lastly, they're asking me about, or stating that if the measure of angle L is 40 degrees, which other angle must be 40 degrees? So this angle right in here, 40 degrees. Now I'll tell you the answer is not angle N. Okay, based on these tick marks here, these being singles and these being doubles, this is not an isosceles triangle. But again, because I have some parallel lines, I do have an angle pair. I have some corresponding angles. Corresponding with this 40 degrees would be right up here. Now I'm not just going to say angle E, because there are two angles possible. I'm actually going to say that as the angle MEF. Or I could have said FEM. If you want to see further examples, you can see the example videos from the book's website, or you can stop in and see me, and we can go over some more questions then.